Everyone, welcome. Today we'll be learning about potentiometers. Potentiometer is the knobs that you see on different devices. They all are a potentiometer underneath. During this activity, you'll be using some hands-on manipulatives. A potentiometer, you'll break it apart. You don't need it. The pictures in are good enough to get away from, to not have to have a potentiometer, but you can have one. It's a little more interesting. Pause the video, do this slide, and then come back and see the answers. So the potentiometer goes about 270 degrees before it hits some kind of stop. And when you take it apart, you're going to actually see that there's a notch kicked into the bottom metal casing, and that's going to catch on this plastic nub right here and stop it from going all the way around. All right, see if you can do this slide now. Go through and figure out where each of these three metal pins are connected to. And this one's going to be good to rotate around and look underneath it and try and see where everything is and what's going on. All right, so it's not too easy to see from this picture, but the left and right pins are both connected to each end of this black ring right here. You can see the other side of it's right here. The middle one's really hard to see. You can kind of see it here. It's connected to a different ring on the inside that's made of copper, not this black material, and it rotates all the way around as well. So the middle ring is not connected to the two outside rings. All right, now give this slide a shot, and then when you're ready to pause the video, when you're ready to see the answers, hit play again. All right, so the two metal pins here, you can see them in the photo here and here. These two are connected to each other underneath the plastic here. There's one piece of metal that goes across. So this is a bridge that acts between the outside ring and the inside ring. So this bridge connects the two outside pins with the middle pin. Yep. So far, so good. So this one let's just talk about, because this one you're not going to be able to just figure out. So it's a little weird that there's a black ring out here and then a copper ring on the inside. So we need to talk about a few things here with resistance. So, whoops. No, I'm struggling. So resistance is a measure of how much energy electrons use. So you can think of resistance as being like, it makes it a material that's more difficult for electrons to move through. It's probably not really that, but it's a good way to sort of approach it. When electrons move through a material with high resistance, they very quickly lose their voltage. So their voltage is turned, their energy is turned into heat in the object. And that's what this black strip is. This black strip is a resistive material. So as the electrons pass around this coil, they're constantly losing a little bit of voltage the whole way through. And this is made in just the right way so that when they get around here, there's just enough time to lose all their voltage. So we have a 5-volt drop as electrons come all the way around. So what does that mean? Remember that there are these two brushes here that allow electrons to leave the outer ring and go to the inner ring when they need to. So we have 5-volt electrons coming onto this pin. They come here right in this position. When they leave, they're like 4.8, 4.9 volts because they've barely gone through any of that black resistive material yet. So they come to the middle pin, and so the electrons here won't be 5 volts. They'll be a little bit less, maybe 4.8, 4.9 volts, 4.7, who knows. And then when you turn that knob, the two brushes move farther around the circle. So the two brushes are here. Now in order for the electrons to get to the middle pin, they have to first travel through a good deal of the resistance. So now they're 3.8 volt or 4 volt electrons when they come over here and come back around to the middle pin. So the voltage on this middle pin will tell you how far along that circle is. The higher the voltage, the closer to 5, the closer the knob is to the 5-volt side. The lower the voltage of the middle pin electrons, the farther they've had to travel through the black ring, and that means the farther right, in this case, the knob is, the closer it is to ground. If the electrons on the middle pin are 0, then you know that the knob is fully to the right. So using this really cool technique, we can tell where the knob is by the voltage of the electrons. Are they 5? Are they 0? Are they somewhere in between? And that lets us know what the voltage is. All right. Let me get this lit up. Of course I did not. Okay. And there's two paths the electrons can take. The electrons can go all the way around the black, skipping the metal, just go all the way around the black to ground. Or they can jump across to the middle pin. Electrons will take the path of least resistance. They actually take all possible paths, but they will take proportionally the one with less resistance. More of them will. So here, the resistance of going across this piece of metal into the metal pin here is almost 0. The resistance going all the way around the outside thing is about 5,000 ohms. So the resistance for the middle pin is way smaller. Almost all electrons will go through that one. A few will still go around the hard way, or the hard way, I don't know how to say it. All right, awesome, good job. I go through this slide and try and predict what you think the voltage will be with the brush. So you can see here's that brush that connects the inside and outside ring. You can see it can pass around. See if you can predict a voltage for all those, and we'll compare our answers in a second. Hit pause, and when you're ready to see the answers, hit play. All right, so you're back. Let's do this thing. So here, the brushes are close to the 5-volt side, so we're going to get a 5-volt electrons on the middle pin here. They're going to jump off right away before losing voltage and come here and be 5-volt electrons. Here, we're forcing them to go halfway through the resistive coating before they jump off and come back down here. So there'll be a 2.5 volt. And here, they're having these 5-volt electrons to go through the whole ring before they can jump off. So here, they're going to be approximately 0-volt electrons. Now on this side, notice I've done something devious and sneaky. I've switched the 5-volt and ground. So I've just unplugged the wires and plugged them in on the other sides. And now, because we're close to the 5-volt side, here's 2.5. I've assigned this as 3 volts on this side. You could have put whatever number that's slightly more than 2.5. It doesn't matter what the number is. The idea is if we're closer to 5 volts, we're going to have a more than half voltage on the middle pin. Here, these 5-volt electrons are traveling all the way halfway, so they're 2.5 volts here, and then a little bit less here for 2 volts. So again, you got to pay attention to where the 5-volt and ground is. Switching those wires simply switches which way is the 5-volt side, which way is the ground side. So which way is full blast volume and which way is off. Okay, and then the last one, the ground is on this side now, so these 5-volt electrons are going through here to get a 2 volt. So these two are 2 volts, even though the knob is facing in different directions because we switched the wires back. On this slide, you're going to try to put together a complete explanation of how a potentiometer adjusts the voltage of the middle pin. And there's something good to know here, that this middle pin, what we do with this is we actually run it to the Arduino so the Arduino can tell what the voltage is. So now if the voltage is 3, we know that where the knob is adjusted to, and we can infer what the user wants to do. Turn the motor up, turn the volume up, make the screen brighter, make the LED brighter. Whatever you want to have the output, you're going to use the input from the potentiometer to know where the knob is. All right, good luck.